Alright, let's have a quick look at how to use trigonometry to find the length of unknown sides in a right-angled triangle. So, this first question asks us to find the value of each point in the triangles below, the two decimal places, and the hint is first choose an appropriate trigonometric ratio. Okay, the way we do that is we look at the angle we're given, 40 degrees, and we look at the names of the sides of the triangle in reference to that. Okay, so this guy here, this is opposite our angle, so I'm just going to put OPP, it's opposite. And this guy's opposite the right angle here, so we know that that's actually the hypotenuse. Okay, and so do we know a ratio that involves the opposite and the hypotenuse? Yeah, we do. That's sine. Okay, and so sine 40 degrees is going to equal to the value of the length of the opposite side divided by the length of the hypotenuse, which is what we're trying to find. Okay, opposite over hypotenuse. Now, this case, we want to find x. So we want to first multiply both sides by x. Book here. It's not writing so bad. Okay. So I multiply both sides by x. I get x times sine 40 degrees equals to 8. And again, I want x by itself, so I'm going to divide both sides by sine 40. Okay. Okay, and then I'm going to get a value for that. I just punch that into my calculator. 8 divided by sine 40. Oops. Cool. And so I've got a value here. Remember, the question asks us to two decimal places. So that's going to be 12.45. Okay, because we're rounding up here. And because it asks for the value, I don't have to put any units of length. Alright, next question, fairly straightforward again. Let's look at what we have. Well, clearly I can see I've got the hypotenuse, and I've got the adjacent side, because it's next to the angle I'm given, which is 60 degrees. Do I know a ratio? Yeah, I do. That's just cos. Cosine. So cos 60 is going to equal to adjacent divided by hypotenuse, 10 over x. Right? And so all we do then is, again, we just try and isolate x in the equation so we can find its value. Here I've multiplied both sides by x again, and I'm going to divide both sides by cos 60. Okay? And the value I get for that, I'll punch it in, 10 divided by cos 60, that is 20. Okay, and it's just the two decimal places, so I can just put 20.00. Okay, this is a worded question now, so let's look at the information we're given. A 1.8 meter ladder leans against the wall and creates a 38-degree angle between the ground and the ladder. Using the diagram below, find the length of D, the distance between the base of the wall and the base of the ladder. I'm going to give us a little picture here so we don't have to draw it. So I know that this angle here is 38 degrees, the ladder is 1.88 meters, and we want to find the distance between the base of the ladder and the base of the wall. Okay, and we can actually translate this into a simple trig problem that looks something like this. Okay, D is here, 38 degrees is the foot, and this is 1.88 meters. This here, if we look at this angle, we know that this side is the adjacent and this side is the hypotenuse, right? And so it's very similar to the one that we just looked at over there. So I'm going to use cos, because that's involving the adjacent and the hypotenuse. So cos 38 is equal to D over 1.88, because that's the adjacent divided by hypotenuse. And then all I need to do is solve for D, and this one's a lot easier because D is in the numerator this time. So all I have to do is multiply both sides by 1.88, and multiply this side by 1.88, I'll just get D, So now I can easily find a value for D. That's just going to be 1.88 times cos 38. Okay, and it should say to the nearest centimeter there, but if you look here, that's 1.48 meters, right? So that's just going to be my final answer to the nearest centimeter. Okay. Last one. A ladder is leaning against the wall, reaches 5.3 meters up the wall. The angle between the ground and the ladder is 73 degrees and 45 minutes. Okay. Now, the question itself is very similar to this one, but they haven't given us a diagram this time. They actually want us to draw it. Okay. So let's look at what's involved. We've got a ladder, and we've got a wall. Alright. And so we know that the ladder, it reaches 5.3 meters up the wall, okay? And the angle between the ground and the ladder, so I'm drawing my ground here, this is my ladder, this is my wall, this is the ground. We know that the angle between the ground and the ladder is 73 degrees and 45 minutes, okay? And they want us, in the next question, to find the length of the ladder. So I'm just going to call that x, right? And so that's how you can find the actual picture, right? That's how you can represent it as a picture. You look at the information they give you and you slowly add it in, right? No need to rush. Once you have this, again, it's a very simple trig problem, okay? All we need to do is, we're trying to find this side. This here is the hypotenuse. And this side, no, this is in reference to this angle, it's opposite. Okay. So all we need to do I know a trig ratio that involves opposite and hypotenuse? Yeah, I do. That's sine. And so sine 73 degrees, 45 minutes is going to equal to the opposite divided by the hypotenuse, which is 5.3 divided by x. And then again, trying to solve for x, so I'll multiply both sides by x. I'll get x sine 73 degrees, 45 minutes. And then I'll divide both sides by sine 73 degrees and 45 minutes because I'm trying to solve for x. So it's isolated. Yeah. Let's just calculate that value now. So that's 5.3 divided by sine 73. So remember to put degrees, I can push this, but if I push that same button again, it will give me minutes. Even though the icon looks the same, this reads as 73 degrees and 45 minutes by the calculator. And that value, it's 5.52, and to the nearest centimeter, right, we look at the first two decimal places, okay, and the one afterwards, it's a 0, so we just keep it as 5.2. So that's 5.52 meters to the nearest centimeter.